In this video, we solve the numerical of orifice meter. So first we understand the problem statement. Orifice meter with orifice diameter 10 centimeter is inserted in a pipe of 20 centimeter diameter. Means one pipe which have 20 centimeter diameter, and in this pipe one orifice meter is installed and the diameter of the orifice is 10 centimeters. So suppose here we write down this given data, and here we see this image of the orifice meter. The diameter of the pipe is 20 centimeter and diameter of this orifice is the 10 centimeter. So first we write down diameter of orifice. It is denoted by DO is equal to 10 centimeters, and from this diameter we can find out the area. For any circular cross section, the area of equation is the pi by 4 into diameter square. So area of orifice, it is denoted by AO is equal to pi by 4 DO squares, and the DO is equal to 10. So by using this equation we can find this area. It is a 78.54 centimeter square. Second is the pipe diameter is given, so it is denoted by D1. So D1 is equal to 20 centimeters, and we also need to find out the area of pipe. So it is denoted by the A1. So A1 is equal to pi by 4 into 20 squares. So we get this answer. It is a 314.16 centimeter square. The pressure gauge fitted in upstream and downstream of the orifice meters give reading of 19.62 Newton per centimeter squares and 9.81 Newton per centimeter square respectively. So here we see that the differential manometers are installed in this image, but instead of differential manometers they install the pressure gauge. Means at the section 1 one pressure gauge is fitted, and this pressure gauge is indicate the pressure value P1 is equal to 19.62 Newton per centimeter square. So here we write down P1 is equal to 19.62 Newton per centimeter squares, and we convert them in a meter. So it is, we need to multiply it with the 10 raised to 4, because 1 meter is equal to 100 centimeters, and here centimeter square is there. Okay, so it is 100 into 100, so it is a 10 raised to 4 powers. So in a numerical there is a different possibilities is there. Okay, so here they install the pressure gauge, but in some numericals they mention that the differential manometer is fitted and they provide this distance x directly. Okay, so these small changes are there in numericals. Now we need to find out the P1 upon rho g. For find out this h, suppose the differential manometer is fitted, then directly h is given, but here we need to find out this h by means in a meter of water columns. Okay, so P1 divided by rho g. So this is the value of P1, that is a 19.62 into 10 raised to 4. It is not 1004, but it is 10 raised to 4 divided by rho, means density of the water, it is 1000 and gravitational force is 9.81. So we get the answer. It is a 20 meter of water. Then P2 is given. So here this is the term P2. P2 is equal to 9.81 Newton per centimeter square, means one pressure gauge is installed at the section 2 and it's give the reading 9.81 Newton per centimeter square. So we convert them in a Newton per meter square. So we need to multiply it with 10 raised to 4. And then we find P2 upon rho g. So here it is a 10 raised to 4. So this value is divided by rho g. So rho is 1000 and g is 9.81. So we get it is a 10 meter of waters. So next parameter is given, that is a coefficient of discharge for the orifice meter is given 0.6, means CD is equal to 0.6, and we need to find the discharge of water through pipe, means we need to find out the Q. What is the value of H? So it is a 20 minus 10, so we get the answer H is equal to 10. So here we mention this given data and we need to calculate the Q. So equation of the Q that we derived in a last video for the orifice meter, the equation of the Q is this, that is a Q is equal to CD into AO into A1 into under root of 2gh divided by under root of a1 square minus ao squares. Now we need to put the value of all the parameters. So first is CD, so it is given 0.6, then into AO, so we already find out it is 78.54, into A1 314.16, into under root of 2gh, so 2 into G. Now G is the gravitational force, and what is the value of G? Value of G is the 9.81, and the unit is meter per second square. But here we put all this parameter in centimeters, like as the area it is in centimeters. Okay, so we also need to put the value of G in centimeter per second square. Okay, means we need to multiply 9.81 with the 100, so we get this answer is the 981. So here we putting this value of G, it is 981. And H, so H is the 10 meter. Okay, means it is this P2 upon rho G minus P1 upon rho G, so it is the 20 minus 10. So 20 minus 10, it is the 10 meter, and 10 meter is converted into the centimeter, means 10 meter is multiplied with the 100, then we get the answer is the 1000 centimeters. So here this H is put at 1000s, divided by under root of a1 square, so a1 is already calculated, it is 314.16, minus ao square, it is 78.54. Then after we multiplied all the parameter of the numerators, okay, and then we get some answer. See, we multiply these all parameters, so we get this answer, it is a 20736838.09, and we multiplied this parameter, not multiplied but we subtract this value. Okay, so it is a 304. Then we divide these two factor and we get the answer is the 68,213.28 centimeter cube per second square. This is the answer of the Q. Now suppose we need to find out this answer in a liter per seconds, then we need to divide it by 1000s. So when we divide by 1000s, we get the answer 68.21 liter per second. So this is our final answers of the Q. So thank you for watching this video. If you learned something, then like the video and subscribe my channel for watching the more video related to FMHM as well as the other subject of mechanical engineering. For FMHM subject, various link is provided in the descriptions as well as in a car. For other subject, I request to visit the playlist of my channel.